Hello learners, today in this video we are going to learn 8th standard science chapter number 15 sound. In this session we are going to learn about how sound is produced and its propagation through different medium. Before we get started, let's take a look at the agenda. The module of this session is production of sound followed by propagation of sound and medium. In this session, we will get familiar with vocabulary words like tuning fork, vibration, compression, rarefaction, sound waves, and many more. Let's begin with our model production of sound, where words cannot be heard, music speaks. Music and sound are part of our everyday life. A sound is a form of energy that gives us hearing experience. We see objects around us with the help of eyes by detecting light from objects. In the same way, ears are used to detect sound. The sound is produced by the vibration of objects and is propagated through a medium from one location to another. The to and fro or back and forth motion of an object is termed as vibration. The motion of objects causes vibrations. In many cases, we can see the vibrations with our naked eyes, while in some cases their amplitude is so small that we can't see them but can experience them. Let us understand the concept of sound produced by the vibration of an object with an example. We might have seen people playing the guitar. In guitar, when they pluck the strings of a guitar, it vibrates and produces sound. The sound produced by it travels through the air, which acts as the medium. Let's get familiar with tuning fork. A tuning fork serves as a useful illustration of how a vibrating object can produce sound. A tuning fork is a fork-shaped acoustic resonator used in many applications to produce a fixed tone. The fork consists of a handle or stem and two prongs. When the tuning fork is hit with a rubber hammer, the prongs begin to vibrate. The back and forth vibration of the prongs produce disturbance of surrounding air molecules. Let's get familiar with the term compression and rarefaction. As prong stretches outward from its usual position, it compresses surrounding air molecules into a small region of space. This creates a high pressure region next to the prongs. As the prongs then move inward from its usual position, air surrounding the prongs expands. This produces a low pressure region next to the prongs. The high pressure regions are known as compressions and the low pressure regions are known as rarefactions. The high pressure regions are known as compression and the low pressure regions are known as rarefactions. Let's see about transmission of sound. As the prongs continue to vibrate, an alternating pattern of high and low pressure regions are created. These regions are transported through the surrounding air, carrying the sound signal from one location to another. The sound produced is transmitted through pressure waves within the object. An object vibrating back and forth rapidly pushes air forward to make way for itself. When a force is applied on an atom, it moves from its original position and exerts a force on the adjacent atom. This motion from one particle to another continues throughout the medium. In this manner, the sound is transmitted through a medium. Let's begin our next module, that is propagation of sound and medium. Sound is a vibration that propagates as an acoustic wave through a transmission medium such as a gas, liquid or solid. A medium is essential for the propagation of sound. Sound cannot travel through a vacuum because there are no molecules that can be compressed and expanded in space. To understand that sound needs medium to travel, we will perform one small activity. Suspended an electric bell in an airtight bell jar. Connect the bell jar to a vacuum pump. If the switch is pressed, we can hear the sound of the bell. If air is pumped out through the vacuum pump, we can't hear the sound of the bell. This shows that sound needs a medium to travel and sound cannot travel in vacuum. So let's summarize what we have learned in this session. Pupils come to know how sound gets produced and they also understand the concept of propagation of sound. Students come to know that medium is necessary for the propagation of sound. This is all for today's session. Thank you.